Toyota is making a third major investment in North Carolina to manufacture batteries.
Toyota has announced a solid-state battery that will shake the entire auto industry. This advancement can render the current electric vehicle landscape nearly obsolete. With projected ranges of up to 932 miles on a single charge and lightning-fast recharge times, this innovation doesn't just challenge the dominance of current EV giants like Tesla and BYD, it threatens to reset the game entirely. For over a decade, the world's largest automaker has teased solid-state capabilities. But now, with commercial deployment on the horizon and a dedicated production plant underway, Toyota is preparing to deliver the battery that could rewrite the future of transportation. Let's get started. The brand need batteries to make EV adoption mainstream. For more than a decade, the auto industry has been steadily pushing toward electrification. Yet one stubborn obstacle has lingered on the road to mass EV adoption: range anxiety. For all the enthusiasm surrounding zero-emission vehicles, many consumers still hesitate to make the leap from internal combustion engines to electric drivetrains. Their concern is simple and, frankly, justified. What happens when your EV runs out of charge in the middle of nowhere, and the nearest charging station is an hour away? Toyota understands this fear deeply, not as a flaw in the customer, but as a signal that the technology has not fully met expectations. That's exactly why they've chosen not to rush forward with half measures, but to carefully develop a real solution. One that's revolutionary in scope. One that puts the battery, not anxiety, at the center of the EV experience. Today, a typical electric vehicle in the United States offers around 247 miles or 398 kilometers of range. For many drivers, that may be sufficient for day-to-day commutes and errands. But real-world driving isn't just about averages. It's about the outliers, the long road trips, the detours, the unexpected weather changes that sap range, and the remote areas with patchy infrastructure. In those moments, the number on the dashboard matters. The time it takes to recharge matters, and the availability of chargers along your route can make or break the experience. With just about 160,000 public chargers across the US, and only around 30,000 of them being fast DC units, the infrastructure is still catching up with consumer aspirations. And while progress is being made globally, charging stations worldwide have increased to over 4 million, up from 1.3 million in 2020. That's still a far cry from the nearly 1.4 billion vehicles on the road. So yes, better batteries are absolutely essential, but Toyota is asking a bigger question. What if range anxiety wasn't just something it managed, but something it eliminated? It's no secret that some of the early entries in the EV market, such as the original Nissan Leaf, while bold for their time, came with serious limitations. A range of just 73 miles or 117 kilometers in 2010 may have served local city drivers, but it did little to inspire confidence for cross-country travel. Tesla capitalized on this gap not just by extending vehicle range, but by building an extensive and exclusive charging ecosystem with over 50,000 superchargers globally. They offered not just range, but reliability. And that mattered. But even now, in a market more crowded with competitors and a public more receptive to electric vehicles than ever before, a fundamental challenge remains: energy density. That's where Toyota steps in. For the past several years, Toyota has been quietly yet determinedly working on what many in the industry consider the holy grail of battery innovation: solid-state batteries. Unlike traditional lithium-ion batteries, which rely on liquid electrolytes and are susceptible to overheating, leakage, and longer charging times, solid-state batteries replace the liquid with a solid electrolyte. The result? A battery that's safer, more stable, and dramatically more efficient. But efficiency isn't just a buzzword here, it's measurable. Toyota's prototypes have already demonstrated the possibility of achieving up to 1,200 kilometers or 746 miles of range on a single charge. Not just city driving range, real-world, cross-country, day-long journey range. And that's not even the most impressive part. Toyota's solid-state batteries are being engineered to deliver a fast charging experience as well, under 10 minutes to reach a usable charge. That's comparable to filling up at a gas pump. Skeptics might say, Toyota has heard this before. And they're not wrong. Companies like Fisker and QuantumScape have made similar promises. However, the gap between lab success and mass market scalability is enormous, and many projects have struggled to bridge it. What makes Toyota's approach different is its deliberate pace and focus on production feasibility. The Japanese automaker is building toward real-world deployment. Toyota is combining over 2 decades of experience in battery chemistry with cutting-edge research and extensive testing infrastructure to ensure these solid-state batteries don't just exist in theory. They are built to last, built to scale, and built for drivers. Even before solid-state, the automaker has been continuously refining battery tech across its hybrid and plug-in hybrid platforms. Toyota's decades-long commitment to electrification has helped the brand master battery longevity, thermal management, and energy efficiency. Still, battery breakthroughs can't solve the problem in isolation. Infrastructure matters too, and Toyota is deeply aware that the next generation EV must be part of an ecosystem. While the brand may not have pursued a proprietary charger network like Tesla, it is investing in partnerships, government collaborations, and energy solutions to ensure that the charging experience evolves alongside battery technology. In Japan and Europe, for example, Toyota has been actively involved in joint ventures to develop high-capacity charging stations. The brand is also working closely with policymakers to accelerate grid readiness, and with utilities to explore smart charging and vehicle-to-grid or V2G integration. There's also an important global dimension to all this. Range anxiety is not experienced the same way everywhere. In urban centres of Norway, where EVs already make up more than 80% of new vehicle sales, the fear of running out of charge has mostly vanished, thanks to a robust network of fast chargers and strong government support. Meanwhile, in vast countries like India or the rural American Midwest, where long distances and limited infrastructure are the norm, consumers are understandably more cautious. This is precisely where solid-state batteries can level the playing field. When a single charge gets you as far as a full tank of gas, and you can recharge in the time it takes to grab a coffee, electric mobility becomes practical for everyone, not just the urban elite. The future of EV batteries. The future of EV batteries is no longer a question of if, but how fast. As the global auto industry accelerates toward carbon neutrality and zero-emission transportation, the battery at the heart of this movement is undergoing a fundamental transformation. Toyota, long recognized as a pioneer in hybrid technology with its groundbreaking Prius, is now leading the charge into the next era of electrification with its bold commitment to solid-state battery technology. Solid-state batteries represent the culmination of decades of research aimed at overcoming the limitations of conventional lithium-ion systems. Where traditional batteries rely on liquid electrolytes, solid-state designs replace them with solid electrolytes, unlocking enormous gains in energy density, safety, and lifespan. Toyota's foray into this advanced battery architecture has been methodical, deliberate, and deeply rooted in scientific rigor. After years of internal development and testing, Toyota is preparing to bring its first solid-state battery vehicles to market before the end of the decade. Solid-state batteries offer the potential to dramatically extend vehicle range. Early Toyota prototypes have demonstrated ranges exceeding 700 kilometers or over 430 miles on a single charge, without the need for oversized battery packs. This leap in energy density is achieved not just by packing more power into the same space, but by reimagining the entire chemistry of the battery. By eliminating flammable liquid components, solid-state batteries also reduce the risk of thermal runaway, making them significantly safer under stress, even in extreme conditions. Charging time also stands to be transformed. Toyota's next-generation batteries are being engineered with the goal of reaching an 80% charge in under 10 minutes, a benchmark that would make charging an EV as quick and convenient as filling a traditional gas tank. That level of performance isn't just hypothetical. Solid-state lab tests have shown charging rates that far exceed those of today's lithium-ion systems. It's not difficult to imagine a near future in which Toyota's EVs seamlessly integrate into daily life without the compromises that once defined electric transportation. As global battery prices trend downward, projected to fall below $100 per kilowatt-hour by 2026, Toyota's goal is to make solid-state performance accessible across a wide range of vehicles, from compact sedans to full-size SUVs and even commercial trucks. That's why Toyota is not only developing solid-state tech for its own fleet, but is also working with global suppliers and battery partners to streamline the entire supply chain. Beyond the numbers and performance benchmarks, there's a deeper ambition guiding Toyota's strategy: to ensure that the EV revolution is inclusive, reliable, and resilient. Solid-state batteries align with Toyota's broader vision of a diversified electrification roadmap that includes hybrid, plug-in hybrid, battery electric, and hydrogen fuel cell vehicles. Rather than betting on a single solution, Toyota is hedging intelligently, acknowledging that different regions, use cases, and consumer preferences will demand different types of clean propulsion. But within that portfolio, solid-state stands out as a long-term game-changer. It's not just a better battery, it's the foundation for a more adaptable and efficient electric future. The broader context also matters. As EV adoption accelerates around the world, battery innovation is no longer solely the domain of automakers. Governments are aggressively pursuing policies to decarbonize transportation, from the European Union's 2035 ban on new internal combustion vehicles to California's Advanced Clean Cars program. Charging infrastructure is expanding rapidly, with ultra-fast chargers becoming more common on highways and in urban centers. Simultaneously, geopolitical shifts and raw material constraints are forcing companies to rethink their reliance on lithium, cobalt, and nickel. Solid-state batteries, by virtue of their compact size and efficiency, may ease the strain on global resources by reducing the need for large-scale mineral extraction and by enabling more efficient recycling processes. In Japan, Toyota is already working closely with government agencies, universities, and corporate partners to create a national ecosystem for battery innovation. This collaboration includes investments in advanced manufacturing, AI-driven battery management systems, and sustainable sourcing strategies. The company's emphasis on long-term durability mirrors the values that have long defined the Toyota brand: quality, longevity, and trust. Meanwhile, the broader EV market continues to diversify. Lithium iron phosphate, or LFP batteries, which Toyota and other manufacturers are adopting for entry-level models, offer compelling advantages in terms of cost, thermal stability, and resource availability. But for premium performance, longer ranges, and ultra-fast charging, solid-state technology holds unmatched promise. Toyota's solid-state strategy is not a replacement for LFP or lithium-ion. It's a complement to them, forming part of a multi-pronged approach that ensures the right battery is used for the right application. Whether it's a family commuter car or a high-performance vehicle, Toyota's future lineup will deliver solutions that match the evolving expectations of a global customer base. Even beyond road vehicles, the implications of solid-state batteries are profound. With energy densities potentially reaching 500 watt-hours per kilogram, the aviation industry is eyeing these batteries as enablers of short-haul electric flights. Similarly, grid-scale storage systems, portable electronics, and robotics could all benefit from the thermal stability and long cycle life that solid-state provides. Now, let's get to the actual point. Toyota has announced a new solid-state battery. While early offerings like the BZ4X garnered a cautious reception, Toyota has quietly and methodically positioned itself to lead the next transformative phase of electric mobility. Unlike competitors who rushed into the EV market to gain short-term market share, Toyota has taken a long view, investing heavily in research, intellectual property, and strategic partnerships to pioneer what it believes is the most revolutionary battery technology yet: solid-state batteries. The company's most significant move came in October 2024 when it announced a partnership with Japanese energy giant Idemitsu Kosan. This collaboration focused specifically on the mass production of solid-state batteries and marked a turning point in Toyota's electrification roadmap. The initial phase involves the development of a large pilot facility for the manufacture of solid electrolytes, an essential component in solid-state lithium-ion batteries. These electrolytes are what replace the flammable liquid typically found in conventional batteries, potentially solving a host of problems that have plagued EV technology. This includes everything from safety concerns to energy density limitations. Construction plans are well underway, with the pilot plant designed to refine and scale the production of solid electrolytes. If all goes as expected, a full-scale production facility will rise in Ichihara City, Chiba Prefecture, with operations targeted to begin by the end of 2027. This timeline puts Toyota on track to deliver solid-state powered vehicles ahead of most of its rivals. The first vehicles to feature solid-state batteries are expected between 2027 and 2028, and will likely be high-end models. These premium vehicles will serve as technological showcases, absorbing the higher costs of early production while giving Toyota a controlled environment to monitor performance, reliability, and customer feedback. At this early stage, only a few hundred tons of solid-state batteries are expected to be produced annually, enough to power perhaps tens of thousands of vehicles. But Toyota is not aiming for an overnight revolution. It's building the foundation for a sustained transformation. By the time mass production scales by 2030, Toyota anticipates a mature solid-state supply chain and a wealth of performance data from its initial fleet. More importantly, the automaker will have refined the integration of these batteries not only into EVs, but potentially into hybrids and plug-in hybrids as well. This balanced philosophy reflects the company's broader outlook on decarbonization. Toyota doesn't view electrification as a one-size-fits-all solution. Instead, it sees solid-state battery technology as a powerful lever within a wider toolbox. For instance, imagine a plug-in hybrid Prius with a solid-state battery capable of 300 kilometers of electric-only range, or a hydrogen fuel cell Mirai using a compact solid-state battery as a high-efficiency buffer. The possibilities stretch far beyond a single vehicle model. So, what can we expect? Performance-wise, the company has floated astonishing range claims for its upcoming solid-state batteries, with estimates stretching from 745 to 932 miles on a single charge, far surpassing the capacity of a conventional gasoline tank. If these numbers materialize, they could obliterate one of the EV sector's most stubborn hurdles: range anxiety. But Toyota has been dangling this future for over a decade, making bold promises and pushing timelines further down the road. The roots of Toyota's solid-state battery program go back more than 10 years. In that time, the automaker has accumulated over 1,000 patents related to solid-state battery technology, working closely with Panasonic in its quest to make this battery breakthrough a commercial reality. On the materials front, Toyota joined hands with Idemitsu Kosan, Japan's petroleum giant, which is using its expertise in refining to supply lithium-based solid electrolytes derived from petroleum byproducts, one of the essential components of solid-state batteries. But for all this work, Toyota's results have remained stubbornly intangible. There was the highly publicized but ultimately unrealized demonstration of a working prototype at the 2020 Tokyo Olympics, a missed opportunity even with the grace period offered by the pandemic's postponement. Since then, Toyota's commitment to the 2027 timeline has quietly softened into a more cautious 2027 or 2028, suggesting internal pressures and technological hurdles are still being negotiated behind the scenes. However, the mood around Toyota's solid-state efforts has shifted. Unlike past years when announcements were mostly theoretical, the company now has skin in the game. Real infrastructure is being built. A solid-state battery manufacturing facility is under construction in North Carolina. This is not just a lab experiment anymore. It's a physical commitment, signaling that Toyota is ready to translate its years of research and patent accumulation into scalable manufacturing. This may also be a response to rising pressure from rivals. Other companies are pushing forward aggressively. Chinese EV manufacturer NIO, for instance, has unveiled semi-solid-state battery packs, while American firm QuantumScape, backed by Volkswagen, is already deep into its testing phase. BMW and Nissan are accelerating their own solid-state battery projects, and Hyundai is investing heavily in research partnerships aimed at commercial deployment before the end of the decade. Toyota's cautious approach, deliberate to a fault, could now become its advantage. The company has long believed in getting things right the first time, rather than rushing to market with half-baked solutions. If its solid-state batteries live up to the projections, not just in range, but in durability, safety, and charging speed, they could offer performance on par with or even exceeding gasoline vehicles, something current lithium-ion EVs still struggle to achieve consistently. These batteries are expected to be safer thanks to their thermal stability, which reduces the risk of fire or explosion, and they promise a longer lifespan, addressing concerns about battery degradation over time. The likely strategy, at least in the beginning, will involve deploying solid-state batteries in Toyota's flagship or luxury models. This allows the company to offset the high initial costs and work out production efficiencies before scaling to mass-market vehicles. By 2030, however, Toyota aims to have a fully developed solid-state battery infrastructure, possibly integrating this technology not only into all-electric models, but also into hybrid and plug-in hybrid platforms. That hybrid angle may turn out to be a trump card. While most of the automotive world has gone all in on pure EVs, Toyota's diversified powertrain philosophy, balancing EVs, hybrids, plug-ins, and even hydrogen, could allow for a smoother, more adaptable transition to solid-state tech across its entire lineup. The groundwork has been laid, the partners are in place, the patents are in hand, and the factories are rising. After years of missed timelines and shifting promises, Toyota may finally be entering the era where its solid-state battery ambitions become concrete. And if all goes to plan, it will be a massive success for Toyota. But one must ask another important question. What are Toyota's competitors doing? Tesla, BYD, NIO, and several other companies have also made significant strides in areas like battery technology, vertical integration, charging infrastructure, and innovative solutions like battery swapping. This competitive field has created both a challenge and a roadmap for Toyota to follow, or possibly leapfrog, depending on how it leverages its resources moving forward. Tesla, perhaps Toyota's most prominent global competitor in the EV space, has carved out a unique advantage with its aggressive vertical integration strategy and relentless pursuit of battery innovation. Tesla doesn't rely heavily on third parties for key components like battery packs or vehicle software. Instead, it designs and manufactures a large portion of these elements in-house. Its gigafactories are massive hubs where battery cells, powertrains, and even vehicle bodies are produced and assembled. Tesla's in-house battery development program, including the much-publicized 4680 battery cell, is aimed at delivering higher energy density, lower cost, and more sustainable production processes. Equally crucial to Tesla's dominance is its proprietary supercharger network. Unlike most automakers that rely on third-party charging infrastructure, Tesla invested early and heavily in building out a global fast-charging network exclusively for its vehicles. This has proven to be a significant value proposition for Tesla owners, who benefit from reliable, high-speed charging access in a relatively seamless, brand-specific ecosystem. However, in recent developments, Tesla has started opening up its superchargers to non-Tesla EVs in select regions, signaling a potential shift toward industry collaboration. For Toyota, which currently lacks a proprietary charging network, this highlights both an opportunity and a gap that must be addressed if it hopes to compete on equal footing in markets where charging convenience can make or break customer satisfaction. Meanwhile, Chinese automaker BYD has taken a different but equally aggressive approach through comprehensive vertical integration. Unlike Tesla, which still partners with companies like Panasonic and CATL for some of its battery needs, BYD manufactures its own battery cells, modules, and packs, along with semiconductors, electric motors, and even EV-specific platforms like its e-Platform 3.0. This level of control over the supply chain has not only helped BYD manage costs effectively, but has also allowed it to scale up rapidly, particularly in China, where it has overtaken Tesla in EV sales at times. BYD's Blade battery is another standout, known for its exceptional thermal stability and resistance to fire hazards, a major selling point in a market increasingly concerned about battery safety. The company's ability to rapidly innovate and iterate on both vehicle and battery tech, all under one roof, gives it a level of agility that companies like Toyota have yet to match. Perhaps one of the most disruptive innovators in the EV space is NIO, particularly for its unique battery swapping model. Unlike the conventional charging model that dominates Western markets, NIO's battery swapping stations allow drivers to replace a depleted battery with a fully charged one in just a few minutes. This model bypasses the lengthy charging times that even fast chargers require and offers a potential solution to range anxiety and battery degradation concerns. NIO has built hundreds of these automated swap stations across China and is expanding into select European markets as well. While the viability of battery swapping at a global scale remains debated, especially due to high infrastructure costs and the need for standardized battery packs, NIO's model introduces an innovative alternative that could appeal to fleet operators and urban users. Toyota has yet to experiment meaningfully with this concept, and doing so would require a significant investment. Another competitor worth noting is Hyundai Kia, whose Electric Global Modular Platform, or EGMP, underpins a new generation of EVs like the Hyundai Ioniq 5 and Kia EV6. This platform supports ultra-fast 800-volt charging architecture, allowing for 10 to 80% battery recharge in as little as 18 minutes. Hyundai and Kia have also announced solid-state battery partnerships and are investing in developing next-generation battery technologies that promise even higher energy densities and faster charging. These capabilities position them favorably against competitors, particularly in regions like Europe, where EV adoption is accelerating rapidly. Toyota, which has announced its own plans for solid-state batteries by the latter half of the decade, is currently behind in implementing high-voltage, fast-charging architectures in its vehicles, though it is moving in that direction with its BZ series. Volkswagen has also adopted a multifaceted strategy to stay competitive. Through its MEB, or Modular Electric Drive Matrix platform, the company has standardized EV production across multiple brands under its umbrella, including Audi, Skoda, and Seat. Volkswagen is heavily investing in building out its own battery cell production facilities under the PowerCo brand, and has entered into multiple partnerships to advance its battery tech. The automaker also aims to cut battery costs by as much as 50% through its unified cell strategy, a plan that mirrors Tesla's cost-focused battery manufacturing goals. Additionally, Volkswagen has rolled out its own charging network initiatives, particularly in Europe, to ensure brand-specific infrastructure support, although it still lags Tesla in this department. General Motors is also worth considering, especially with its Ultium battery platform, co-developed with LG Energy Solution. Ultium is designed for flexibility across vehicle types and emphasizes reduced cobalt usage and improved energy density. General Motors has committed to a fully electric future, with a pipeline of upcoming models and investments in battery manufacturing facilities in the United States. The automaker is also exploring wireless battery management systems, which could improve battery longevity and reduce weight and complexity. General Motors' aggressive pivot to electrification stands in contrast to Toyota's slower, more measured EV rollout, though Toyota has long emphasized hybrid and hydrogen technologies as part of a broader decarbonization portfolio. Interestingly, Toyota has recently acknowledged its lag in the EV race and is attempting to catch up. It has announced partnerships with Panasonic for solid-state battery development, investments in new EV-dedicated platforms, and a restructuring of its production model to better align with the principles of vertical integration. The company has also pledged to deliver a range of EVs with significantly improved range, performance, and charging times by 2026, including models featuring its next-gen battery packs. Furthermore, Toyota has hinted at an ambitious goal of achieving a 1,000-kilometer range on a single charge through its advanced battery research. For Toyota, the road ahead is complex, but it has a clear shot at peaking in the EV market. Why Toyota is poised to be at the top. Toyota is strategically positioned to lead the global EV market. This advantage stems from Toyota's pioneering advancements in solid-state battery technology, its diversified powertrain strategy, and its resilience amid geopolitical challenges that are currently impacting other automakers. Toyota is at the forefront of solid-state battery innovation, holding over 1,300 patents in this field, more than any other company globally. These patents encompass critical areas such as materials science, manufacturing processes, and battery management systems, underscoring Toyota's comprehensive approach to solid-state battery development. In collaboration with Idemitsu Kosan, a leading Japanese energy company, Toyota is working to mass-produce solid-state batteries by 2027 to 2028. This partnership focuses on developing sulfide solid electrolytes, which are essential for creating batteries that are safer, more efficient, and have higher energy densities than current lithium-ion batteries. Toyota's forthcoming solid-state batteries are projected to offer driving ranges between 745 to 932 miles on a single charge. Even at the lower end, this range surpasses that of most internal combustion engine vehicles, effectively addressing range anxiety. These batteries are also expected to support faster charging times and longer lifespans, enhancing the overall convenience and cost-effectiveness of EV ownership. Unlike competitors that focus solely on battery electric vehicles, Toyota employs a diversified powertrain strategy that includes hybrids, plug-in hybrids, hydrogen fuel cells, and battery electric vehicles. This approach allows Toyota to cater to a broader range of consumer needs and adapt to varying regional energy infrastructures. By integrating solid-state battery technology into its existing hybrid and plug-in hybrid models, Toyota can incrementally enhance vehicle performance and sustainability, facilitating a smoother transition from traditional to fully electric vehicles. While Toyota advances its EV technology, competitors like Tesla are facing significant geopolitical hurdles. Tesla's sales in Europe have plummeted by 45% amid widespread boycotts linked to CEO Elon Musk's political affiliations. In China, Tesla has suspended new orders for certain models due to escalating trade tensions and tariffs. In contrast, Toyota's strong presence in Asia and its strategic partnerships within Japan position it to navigate these geopolitical complexities more effectively, ensuring stability in its operations and supply chains. Toyota is investing heavily in manufacturing infrastructure to support its EV ambitions. The company is constructing a solid-state battery plant in North Carolina, aiming to commence production between 2027 and 2028. Additionally, Idemitsu is building a large-scale plant in Chiba, Japan, to supply essential materials for Toyota's solid-state batteries. These investments demonstrate Toyota's commitment to scaling up production and ensuring a reliable supply of critical components for its next-generation EVs. Toyota's extensive experience in vehicle manufacturing, combined with its innovative advancements in battery technology, positions it as a formidable leader in the global EV market. The company's diversified product lineup and strategic investments enable it to meet diverse consumer demands and adapt to various market conditions. As competitors grapple with political and operational challenges, Toyota's steady progress and strategic foresight underscore its potential to dominate the EV landscape in the coming years. With strategic partnerships, significant manufacturing investments, and a commitment to innovation, Toyota can peak the EV arena. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.